Welcome to the average value of a function, mean value podcast. And this problem we started in class. We kind of read through it, and I decided I'd do a podcast on it. And we're looking to do a Riemann sum. It doesn't specify which kind of Riemann sum, so I'm going to just choose a right Riemann sum. All right, let me just do the setup here, and then I want to show you how to use that table for the right Riemann sum. All right, so for the right Riemann sum, we're finding the average value. So we need our interval. If you notice, we go from 12 a.m. to 12 a.m., so it's a full day. All right, so that'd be 24 hours. So 1 over 24, right, and then we have the integral. And then we're going from 0 to 24, right, to represent the 24 hours. And we're going to integrate t of t dt. If this is an FRQ problem, you want to show what it is you're doing. The first step you'd want to do is write the formula. And you'd want to show that, okay, from the average value, we're going to have to divide 1 over 24 because that's our interval length. We're going to be estimating the area under the curve from 0 to 24, and we're going to use Riemann sums. But we're going to show that what we're doing is we're approximating an integral, right? So you want to have that part in, and then, right, we can change that t of t and write it in as our Riemann sum. Now, when you look at this, we're not used to seeing intervals. We're used to seeing numbers. So I'm going to make this a little bit more user-friendly by putting just a single number there. Because I know when I looked at it, I'm like, okay, which interval do I take? I'm doing a right Riemann sum, which means I'm using these values. And it kind of is confusing, I think, with these ranges in here. And I think it'll make it a lot clearer if we just put the starting and the ending. So we're starting at 0, right? And then this would go all the way to 7 a.m. So 7 hours have elapsed here, right? So from 12 to 7, if I'm thinking of this as one bar, right? This has gone from 0 to 7, and then here we've gone from 7 to 9. So now we're 2 more hours, right? So I want to put 9 because I haven't gone 9 hours. I've gone 2 more hours. So I'm starting at 0, right? That's to 12 a.m. And then to get to 7 a.m., I've gone 7 hours. To get to 9 a.m., I've gone 2 more hours. To get to 1 a.m., I've gone 4 more hours. To get to 4 p.m., we've gone 3 more hours. And then 3 more hours, 2 more hours, and 3 more hours. Let's make sure that adds up to 24. Right? Because when I was trying to work with the intervals there, my time didn't add up to 24, and you want to make sure it adds up to 24, right? So we've got 0 plus 7 plus 2 at 9 plus 13. 3 more give us 16, 19, and then 5 more gives us 24. So we got 24 hours there. Okay, so we're replacing those intervals with just a time, an x value. And I think that makes it a little easier to work with. Because now we can see that first bar is really 7 in width, right? Not 5 in width. And that's what you kind of think of if you don't rewrite this as the amount of elapsed time. So this is my bar, right? This is my bar from here to here, right? This is the width. So this represents the width of my bar, what I just circled. And that 57 is the height of my bar, right? So that's going to make this easier to figure out. So this is the width of our bar. So now it's just going to go from here to here. So it's going to be 2 more hours, and then this is the height of my bar, right? So now let's write our values in. So we're not using the 42 because I chose to do a right Riemann sum, and for no particular reason except I'm always right. No, I just chose a right Riemann sum. There was no reason at all. All right, so we have 57 times 7 hours, right? So that 7 hour, the 57 is representing the 7 hours, right? And then we've got 72 times 2 hours. So if you have a problem like this with an interval, just rewrite this is your start, right? So this was my 0 because I'm starting at 0. So for a time like this, just write this one as 0 for the first number, and then what's the amount of time from 12 a.m. to the last number in the interval on the second bar. And if you do that, you'll set this up correctly. All right? So we have 57 plus 7, 72 plus 2. I was short, by the way, 2 hours when I didn't do that, when I didn't rewrite this. That's why I redid this. Of course, you don't know that, but I redid this. And just by putting the numbers, I'm making sure I'm getting it correct. 84 times 4, and then so forth. So each of these up here represents the elapsed time from the previous interval. So 89 times 3. Oh, and I almost forgot to put in, I was so worried about those bars, don't forget parentheses here and 1 over 24. And then, what am I up to? 75 times 3. And then 66 times 2. And then 52 times 3. All right, so we would just add these values up. And so this is all of A. So this is it. We finished A. Add them up. Just show what you're doing. All it says is to write the formula for the average temperature of the day. We've done that. We've shown that we're going to integrate and evaluate, and we're integrating using the Riemann sums, and we're showing what values. This is a perfectly good answer. Okay? And actually, they'd probably take this for B as well. This alone on an FRQ might give you both A and B. Right? But this is an easy calculator problem, and if you have the time, all we have to do is multiply and divide by 24. So maybe I'll do that real quickly, and then I'm going to end this tape, and then I'm going to pick up on the next one with volume. So I've got 75 times 3, and oops, I missed my whole line there. 55 times 7 plus 72 times 2 plus 84 times 4 plus 89 times 3 and 75 times 3 and 66 times 2. And hopefully I'm not missing any numbers because I'm not even looking at what I'm typing. 52 times 3. And then divide by 24, and let's see if I get a sensible answer. I get a sensible answer. 68 point, I'll round it to 2 decimals, 0.542 degrees. And that's in Fahrenheit, and that's my B. And I'm done, all right? So this problem seems a lot trickier than it is. Use my suggestions there about changing those time intervals to just elapsed time. And the key here is that first bar is going to go from our starting time to the end of the first bar. And then after that, you'll have it all set up correctly for the right Riemann sum. If I was going to do a left Riemann sum, I would do the same thing, except my ending bar would go from 7 p.m. to 12 p.m. That's the only difference, right? If you have any questions on this, let me know. Next podcast is going to be a volume podcast. And I warn you, the first problem's a little tricky, but it gets better after that. All right, see you in the next podcast. Bye.